Hello class, welcome to the final segment in lecture 4, and in this segment we'll take a look at sort of an exercise that will sort of check your understanding on effective gravity and centrifugal force as it relates to our planetary system, otherwise known as Earth. So again, just like the previous exercises, I'll just read out the problem to you and then give you some time to pause the video and work through the exercise yourself. So using the concept of effective gravity, what would be the weight in newtons of a 75 kilogram person that is situated at the equator of Mars? And some values that you might find useful. The acceleration due to gravity on Mars is 3.8 meters per second squared. The radius of Mars is 3,391 kilometers. A day on Mars is 24 hours and 37 minutes. And the number of movies made about Mars is 36. So with that, I'll go ahead and ask you to pause the video, take 5 to 10 minutes, work through that, and try to arrive at some sort of solution. So hopefully you arrived at some sort of answer, and hopefully that your solution looks something like what you're about to see on the screen. So if we take a look at the solution, so our end goal here is to find the force of weight that a person will experience on Mars's equator. So that makes use of an equation from physics where the force of weight is equal to the mass of the person times the acceleration due to gravity. But if we're looking at effective gravity, the effects of effective gravity, then we have to use G sub E, effective gravity, in place of the regular acceleration due to gravity. So doing that, we get this equation up here, and then we go to determine what exactly the effective gravity is, and that's going to be equal to the acceleration due to gravity on Mars, just the regular value, minus the angular velocity of Mars's rotation, times the radius of Mars, and then times the cosine of our latitude. And since we're at the equator on Mars, we're interested in the equator, our latitude is in fact 0 degrees. So our force of weight will just be simply equal to mass times this entire expression substituted into effective gravity, and then from there we just simply plug in the values that we were given. So our mass, 75 kilograms, the acceleration due to gravity on Mars, 3.8 meters per second squared, minus, and hopefully you used the angular velocity of Mars and not the angular velocity of Earth, even though those two numbers are roughly the same. They are in fact a little bit different. So the angular velocity of Mars is 2 pi over 88,620 seconds. So you have to account for the fact that there are 37 extra minutes in Mars's orbital cycle. So that's going to change your denominator a little bit. And then the radius of Mars, 3,391 kilometers, which we have to convert into meters. Hence this conversion factor times the cosine of our latitude. So our value since we're at the equator, that's just simply 0 degrees. And if we plug the entire mess into a calculator, we get that the force of weight that a person will experience at the equator on Mars will be 287.32 newtons. So hopefully that's the answer that you got. If so, awesome. If not, make sure you understand at least the solution and the process involved. So that's going to do it for this segment. And with that, that will also conclude lecture 4. So I'll see you all in the next lecture where we actually start talking about Coriolis force. So I will see you all then.